Finishing up here with example 12, we need to find the acute angle theta. It says do not use a calculator unless absolutely necessary. So I want to find the angle such that the sine is 1/2. Okay, now I have my chart earlier that I can refer to that has a sine of 1/2. If the sine is 1/2, the angle must be 30. So even though I don't need to use a calculator, I can use my chart. So my angle needs to be 30 degrees. Find an angle such that the tangent is the square root of 3. If the tangent is the square root of 3, the angle would be 60 degrees. So theta is 60 degrees. If the secant is the square root of 2, secant square root of 2, it means that the angle is 45 degrees. So theta is 45 degrees. And if the cosine is 0.75, that's 1/4. That is not on my chart. I have cosine values of 1/2, √3/2, and square root of 2/2. 0.75 is not on the list, so we're not able to compute that one without more information or more identities that I don't have yet. I may be able to compute that one by hand in later sections, but at this point I cannot. So we are going to use, first of all, let me write down something. We're going to use the arc cosecant feature, so that angle theta is equal to the arc cosine of 0.75, or same function, different notation, the inverse cosine of 0.75. Now, as I go back into decimals, I can type either one of those. Oops, wrong button. I can type arc cosine of 0.75, or I can type or click the functions button for the arc cosine of 0.75. So this angle, theta, is approximated as 41.4096 degrees. Notice on, sorry, one of my pages was moved up, but notice on any of these, I could have used a calculator for the first three. I was told not to because I want to start remembering that chart and remembering these. Another trick for remembering them that might come in handy is that I know that 1/2 is related to the angles 30 and 60, so if I want to know which of them has a sine of 1/2, I can think about two triangles. So the 30-degree angle has a longer adjacent and a shorter opposite. The 60-degree angle has a taller opposite and a smaller adjacent. So the 30-degree triangle is going to have an opposite that is smaller, so it's going to have the 1/2 for its sine value, and the 60-degree has a taller opposite, so the sine is going to be the √3/2 value. That's one of the ways I remember is that the 30-degree is a shorter angle, so its sine value is smaller. Now it has a longer adjacent, so its cosine value is larger. Okay, so it has a short opposite and a long adjacent. Just for remembering, the sine of 30, that's a short opposite, so it's 1/2, and the cosine is supposed to be a c. The cosine of 30 has that long adjacent, so it's a square root of 3/2. 60 is the opposite. 60 has a short adjacent and a long opposite, so it's the reverse of that triangle. It would be helpful for memorizing.